Before I start this video, let me take 30 seconds to tell you something about Exergic. Exergic is India's most trusted and most experienced institute for online GATE preparation. I am Chandresh Mahajan, founder and chief educator at Exergic. I am an All India rank 37 in GATE Mechanical Engineering, an ex-Indian Oil officer having 7+ years of teaching experience as of now. These are the GATE 2021 Mechanical Engineering toppers from Exergic. You can find their preparation strategy on Exergic's website. To know more about our GATE courses, you can visit our website or contact us on these details. Also, you can download Exergic GATE preparation app from Google Play Store. The link is available in the description of video. Let us have a look at this question, which says that velocity distribution in a 3D incompressible steady flow, three-dimensional flow, all the x, y, and z axes are involved, incompressible and steady, is given by this. This is the velocity field for this flow. V vector is equal to 3 plus xi plus 4 minus 2yj plus z minus 1 k cap. The magnitude of volume flow rate crossing the surface ABC is how much meter cube per second. Look at this graph here, x axis, y axis, z axis. You can see that there is a surface which is intersecting all of these three axes at different points. X axis, it is intersecting at 1, 0, 0, means at 1 unit, because obviously for x axis y and z both will be 0. Similarly, it is intersecting y axis also at 1 unit. This is 1. X and z component are 0, y component is 1. And here also z component is 1, rest are 0. This is how this area is, right? And you have to tell that for this given velocity field, how much will be the volume flow rate crossing this area ABC. It's an area, right? How much volume flow rate will be coming out of this area, how much fluid will be flowing through this area per unit second. It looked like a question which is complicated, but trust me, it's a very easy, very simple question. I'm solving it. Meanwhile, you also try. So if you tried the question and you were able to solve it, very good. Although it's an easy question, but it can confuse aspirants. How much should be the right answer for this question? 3 meter cube per second. If you have not tried it yet, again I am giving you a chance. Pause the video, try to solve it. I have told you what answer to reach. Okay. Let me discuss the question. The question has mentioned that it is an incompressible steady flow, right? Which means that if I select any volume, imaginary volume in the flow, whatever mass or whatever volume enters into that must leave also. It is incompressible, so it cannot get compressed. It cannot happen that 2 meter cube of volume entered in any region per second and only 1 meter cube got out. It is not happening. Are you getting my point? Suppose there is a fluid. In the fluid, I have assumed a hypothetical, imaginary region. Through that region, fluid is entering also, fluid is leaving also. But the type of flow is incompressible. It means whatever is the volume, that is not going to change. Volume of the fluid is not going to change. Of any volume, any packet of fluid, its volume will not change. So if 2 meter cube of fluid entered into that imaginary region, 2 meter cube has to move out because it is incompressible as well as steady. With time also it will not change. Getting my point? So whatever is the volume coming into hypothetical region, it will not get compressed, and since it's a steady flow, the same volume is going to get out. It is not getting accumulated in the region, in that hypothetical region. It's a steady flow. It has to move out. Flow is continuing. What is that hypothetical region that I am talking about? the volume formed by O, A, B and C. This ABC plane with all the three other planes is forming a volume, right? With X plane, with Y plane and with Z plane. Three planes are there, right? This is one plane, this is another, this is another. These three planes in combination with the ABC, they are forming a volume, right? Through that volume, fluid is entering and fluid is leaving. So what we can do here is that we can assume that through X, Y and Z plane, through these three shaded planes, the fluid is entering. Okay, fluid is entering in a particular direction, but fluid has a component in all these three directions. This is the component of velocity along X, along Y, along Z. So fluid has a component along all the three directions. So fluid is entering on these sides and it is leaving from ABC. Through this ABC, ABC is a surface. In reality, what is happening? In reality, fluid is flowing through the surface ABC, imaginary surface. From one side it is entering, from other side it is leaving. It is an imaginary surface in the fluid. In any flowing water, you can imagine any surface. That surface you can say it is ABC. You can orient the X, Y, Z axis accordingly, right? But we have included X, Y, Z, these three planes also to form a volume. And why we have done that? Because question gave us that velocity has three components, one along X, one along Y, one along Z. And look at this diagram now. The component of velocity along X direction will enter from which phase? Let me repeat. This volume that I have imagined, how many phases it has? 4. One is ABC, other is OBC, other is OAC, and last is OAB. These three phases and a plane, they are forming a volume. Whatever is the velocity component along X, means along this direction, like this, from where it will enter? It will enter from O, B and C. In reality, fluid is having a definite direction, but its components are having different directions. So we can very safely assume that Y velocity component, the component of velocity along X direction is entering from OBC, from a plane perpendicular to X. This is X axis. This is a plane perpendicular to X axis. I am saying that velocity has a component along X. So if velocity is in this direction, fluid is flowing in this direction, assume, then from which plane it will flow, it will pass? This plane, plane which is perpendicular to X axis, right? In the diagram here, X axis is this one, OBC is perpendicular to X. So velocity component along X will pass through OBC, right? Similar thing we can say for other two planes also. Along Y will pass from OAC. Along Z will pass from OAB, right? So velocity which is coming from one side of ABC, from back side of ABC, will come from all the three sides and it will leave from ABC. This is again repeating our assumption. Maybe it can enter from ABC and leave from all the other sides. Direction we don't have to bother, only magnitude it is asking us. Clear? And now let us try to find out how, let us try to solve this question. So this plane, since I told you, is present in a incompressible steady flow. So whatever volume flow rate is entering from those three sides must leave from ABC. So QABC should be equal to, means volume leaving ABC should be equal to the volume flow rate approaching ABC from the other side. And from the other side it is approaching from these three planes. So Q through OBC, Q through OAC and Q through OAB. And I just told you that Q through OBC, this is OBC, will be equal to area of OBC multiplied by volume along X direction. Because if this is OBC plane, the velocity crossing OBC plane perpendicular to it will be along X direction. So Vx along X direction component will be passing through area OBC. Got my point? So Q of OBC will be velocity multiplied by area, velocity of X, area of OBC. Discharge through OAC will be equal to area of OAC multiplied by the velocity in the Y direction. Velocity in the Y. Similarly, discharge through OAB or AOB will be equal to area of OAB multiplied by velocity along Z direction. This is what it is. Vz, Vy, Vx. We know already the velocity in X, Y, and Z component. Simply put them here. Area. All the three triangles are intersected at the same unit. 1 unit, 1 unit, 1 unit, right? So this OB, 1 unit, OC, 1 unit, OA, 1 unit. So whatever triangle area you calculate, it will be half base and height. Base is 1, height is also 1, all three of them. So area will be half for all of them. And components, we already know 3 plus x, 4 minus 2y is y component, z minus 1 is z component. Now what to do? To find out Q of ABC, we need to have the values of x, y and z. How to know that value? Apply basic mathematics, very basic mathematics. This expression we have written for which plane? For OBC plane, right? The first one. Where is OBC plane? O, B and C. This plane is YZ plane, right? YZ plane is lying at x is equal to 0. Look at the diagram. YZ plane. For YZ plane, x is 0. For XY plane, z is 0. For XZ plane, y is 0. Right or not? Here we need to have which plane? OBC plane, which is YZ plane. So x will be 0. So here x will be 0. For OBC plane, x is 0. Similarly, for OAC plane, y is 0. So this y is 0. And similarly, for last OAB plane, z is 0. Put these values. This is 0, this is 0, means y is 0, z is 0. You put it, you will get 3 here. 3 multiplied by 1 by 2. Here you put y, you will get 4 by 2, which is 2. Here you put z0, you will get minus 1 by 2. And you solve them, you will get 3 meter cube per second. How easy question. I will call it a simple mathematics question, right? Only concept needed to be applied was this, which you concluded as a result of this. But if such question is asked in GATE, I know many aspirants will get confused. This does not use any difficult concept. It is a basic concept of steady incompressible flow. Who doesn't know that for steady incompressible flow, this is something that we can write, right? And don't even think that, sir, we have to imagine that there is going to be a volume, this volume, how to imagine, how to think about this in the exam. Volume you don't have to imagine. I am quickly telling you the thought process. ABC is a plane. Whatever volume, whatever fluid is coming from one side has to leave from the other. One side of ABC is towards the origin. Look at this diagram. ABC, one side is towards the origin, other side is away from the origin, right? That side, from that side, if any fluid approaches, what are the three areas available to it? OBC, OAC, OAB, right? AB plane, origin side, three areas are available. Velocity has clearly given in these three directions. What else you can do other than this? Getting my point? That is why whatever question you get in GATE, no need to be underconfident. Basic concepts are enough to get you 90 plus marks. If you don't do silly mistakes, the concepts that you know are enough to make you cross 90 marks easily. And if the day is good for you, you may even cross 95 marks. Toppers cross 95 marks, right? Whatever are the types of questions asked in GATE, any year you pick, any difficult year also you pick, I am telling you now, if you sit calmly, you look at the questions, how they are solved, you will not find more than, in maximum cases, more than 3 or 4 such questions which are really good and cannot be solved in the exam pressure. But other than that, questions are easy. Any paper you take, I know that especially the GATE 2020 paper, aspirants get very, they think that it's very difficult. But trust me, on a personal level, I have talked to many aspirants who were successful in 2020 and who are not successful. All of them, in their true senses, in their true logic, they say it, that sir, we did a lot of silly mistakes. We were easily touching 90 marks, crossing 90 marks, but we did silly mistakes. Ultimately, type and the number of such questions or weightage of such questions, which will be very difficult to think in exam. Trust me, take any year, calmly sit and go through them. That is not more than 5, 6, at max 7 marks, at max. All the other questions are doable if you avoid silly mistakes. I am not considering aptitude part here, right? Aptitude section, it used to come difficult initially, but nowadays it is very much scoring. Students are easily able to score marks in aptitude. I am considering full marks there. After that, I am doing the calculation. Aspirants make mistake in aptitude also, that reduces their marks somewhat. So keep your mind calm. Even if you get a question which looks difficult, don't judge it. Very simple looking question can be extremely difficult, and difficult looking questions can be very easy.